Hello everyone, and welcome to today's iTwin Platform Developer Webinar, where we're going to learn about bringing iTwins into Unreal. My name's Jason Slocum. I'm a Director of Product Management for Bentley's iTwin Platform, and I'm going to be your moderator for today's session. Today, I'm excited to be joined by Michael Belusev, Software Engineer for the iTwin Platform Development Team, who is going to introduce us to the iTwin Datasmith exporter, which allows you to quickly and easily move your iTwin into the Unreal Engine. Unreal is one of the most popular rendering engines that can help simplify the task of creating high-fidelity, interactive presentations. Using the iTwin Datasmith exporter, you can save hours or even days importing your iTwin into Unreal. Today, Mike's going to walk us through how to take an infrastructure digital twin that has been created with the iTwin platform, also known as an iTwin, and use the iTwin Datasmith exporter that will streamline the process of exporting geometry and metadata from your iTwin and then importing it into the Unreal Engine. He's also going to show us how you can configure and play a SYNCHRO 4D schedule animation for your iTwin in Unreal. As always, we'll wrap up today with Q&A. Please post your questions into the Q&A widget that you see on your screen during the presentation. And after Michael's done, we'll come back and take your questions. Since Michael's presentation is going to be largely focused on how you take an existing iTwin and bring it into Unreal, I'd like to first kick us off with a quick refresher on how you can create your own iTwins. If you've joined any of our previous webinars, you may recall that one of the strengths of the iTwin platform is in its ability to align and aggregate a lot of different types of engineering data from a wide variety of formats such as MicroStation, Revit, and shapefiles, which can then be incorporated into your iTwin. You can find a full list of the file types supported and learn more about how the iTwin platform can help you synchronize your engineering data by going to developer.bentley.com, clicking on Documentation, and then choosing the synchronization service. All right, I think that's enough in the way of background for now, so over to you, Michael.
Thanks, Jason. Hi, I'm Michael Belusev. I'm a software engineer at Bentley Systems expanding the iTwin platform. I'm also the lead developer of the iTwin export for Datasmith, which helps you integrate your iTwins with Unreal. If you're new to the iTwin platform, it is an open cloud platform to enable creating digital twin applications across the infrastructure lifecycle, and you can find out more here at developer.bentley.com. If you're new to Unreal Engine, it is an industry-leading game and real-time content engine which is used to create interactive and static media. In the architecture, engineering, and construction industries, it is used for things like lighting studies, high-quality demonstrations, and even developing entire custom applications, including with AR and VR. You can find out more at unrealengine.com. Now let's navigate to the iTwin for Unreal page. Under Documentation and iTwin for Game Engines on the right here, we find the iTwin for Unreal page, home of the iTwin export for Datasmith. The iTwin export for Datasmith is a free standalone application that helps you export your iTwin's geometry and data into Unreal's Datasmith format. This lets you bring into Unreal all the formats you've connected to your iTwin and leverage Unreal's data prep pipeline to automate transforming your scene as you import it using your iTwin's data. We also support a special combined scene export mode for large models where performance of many Unreal Engine objects could be a problem, where the scene's static meshes are combined and the animation can be controlled with a special API. There's a download button over here for the iTwin export for Datasmith, or you can scroll down and check out our documentation. You can also find our tutorials either here or all our tutorials under the special section. But we're going to get started getting our iModel into Unreal by opening the exporter, which you must have downloaded back at the /Unreal page. Over here. Let's open it up. So we come to the sign in page. If you haven't signed in yet, if this is your first time installing it, then you will have a new tab in your browser open. If you can't find it, it automatically opens, so look for it. And that lets you sign in using whatever credentials you already have in your browser, so it's a little bit easier. We also have at the top here, once you've signed in, or actually before, a feedback button to go to our ideas portal where you can request features or vote on features that other people have requested, or you can go straight to the documentation from there. But other than that, we can navigate through projects. You could look at all of them, but I'm just going to go to one that I set up for this that's already in my recent projects list. And I'm going to open it up. But before I do, I just want to note that here's the install button for the iTwin Unreal Datasmith plugin, which we're going to need to install into our Unreal project. So you can always go back to this page to install it, but it's important to do it. Sometimes you might want to do it before you even open your thing, but we haven't made our Unreal project yet, so we're not going to do it yet. So instead, we're gonna just go ahead and open our iModel. You can hit View or click on the image. You could also just directly export without even viewing it, but there are a few more options inside the viewer itself, so we're just going to hit View. Mine opens pretty quickly because I have already opened this one before. If yours isn't cached and you haven't opened it yet, it may take a bit to open. When I open it up, you see that there's sort of nothing interesting going on here. That's because this iModel has a schedule, which is important for us because one of the features of the iTwin export for Datasmith is that it will import your schedule data. So you can get your animations straight into Unreal without any work, and we want to see that in Unreal. So we have this building process, which we're going to take a look at in Unreal. And now we actually have everything here. So another thing that we can do with the viewer, which might be important, is the properties panel. You might have it at the bottom if you haven't opened it yet, but you can click on elements and check out some of their properties here, depending on how they were imported or what your iModel is made up of. Depends on what metadata and what properties you will actually have. If you notice, for instance, that you hover something and you only want, so let's see, so you hover this floor, but when you click it, it selects everything. You just need to change your selection scope from top assembly to element. And now when you click on the individual element, it'll only select that. And that's going to be useful because we can now hide those to restrict it from our export. So I just hid that element, and you can actually use some of the filtering features for the export to not have that thing exported. We actually have 3 export buttons at the top here when you're not using the visibility tools. So we have the standard export, which is going to do what's called a combined mesh export that takes pretty much all the meshes in your scene that don't have some sort of transform animation that moves it around. Anything that doesn't move but might have any visibility animations or cutting plane animations, that's going to be combined into one mesh because that's usually much more performant in large scenes. This scene in particular, I know renders extremely slowly, like 2 frames per second if I do not use this option. So it's a good option for large scenes. So we're going to be using it here. It also just does all the other default export options. You can set the options by using the advanced export, and you can also choose various filtering features there. Before I even go into these, this middle export button just exports the current view, which is one of the view filter options that you will have in the advanced export. And exporting the current view just means like, hey, if I hid this, then that's going to be not in the export anymore. So let's take a look at the advanced options here. So we have some metadata behavior. Unfortunately, when you are combining all the meshes, you'll notice, so if I switch this to element metadata, when I click this, it's gonna get rid of that and tell me element labels only, and it's actually going to disable the other options. Because when you're combining all the meshes, you actually don't really have the granularity of actors in Unreal to use Datasmith's metadata system, and it can be slower to include the metadata into the file since there's a lot of it. So we just you aren't allowed to get the metadata when you're combining your mesh. For smaller scenes, or if you're hiding a bunch of stuff, then in large scenes you might have to hide a bunch of stuff, but for a medium-sized scene or for a scene where you hide enough for it to be possible, you don't have to combine meshes, and then you can use the Datasmith visual data prep tools to do whatever changes you like. So sometimes hiding parts of the scene or processing it differently, exporting it differently so that you can use Datasmith recipes might be useful depending on your use case. This metadata behavior, so it only applies when you're doing the separate objects, when you're not combining the meshes. You can either get only the element metadata, which is not going to include what's called element aspects. It will include one kind, which is the element source, external source aspects. So basically just where did this element come from? So it's the information on the element itself and the where did it come from. If you need all the metadata, like one of your properties isn't showing up, then you can go for all metadata, which is the slowest option. But it will put all the metadata in your Datasmith file for you. So you'll be sure to be able to find whatever metadata popped up in the properties panel. You'll be able to see it in Unreal and select on it when doing visual data prep recipes. The next thing that we have here is this origin offset, which lets you, for very large scenes, maybe you want to move them around while exporting. It defaults to moving the object to the center of Unreal, because for very large scenes, especially ones that are placed very far from the origin, if you don't do that, then you're going to have precision issues in Unreal. Like the geometry will be too far away from the center to be accurate. So this just automatically recenters it for you, but you can change it back to 0, 0 if you like. And finally, we have filters. So by default, it doesn't filter anything, but you can switch to filtering on a view. The current view is the one that you that I mentioned before. It's the same thing as that current view export button, where it just takes whatever is currently hidden and whatever is in the current view, basically. You can also switch to either saved views that you have or any view definitions that are in the model. Because this iModel comes from some connected SYNCHRO data, I have a couple of SYNCHRO view definitions that were created during the connection, but I also have 2 saved views here, which we'll look at the saved views widget in a second, that we can manage there. But we can select them here during the export, and that way we don't need to manually choose the saved view every time before we hit export. So I'm going to hit the Save Views widget. So here we have the list of views, and then the desktop views are the same as what I called view definitions earlier that come in through your connection. We can create views, we can hide something, and then create a new view. So I'm just going to select a couple elements here, and I'm going to hide them, and then open this and just create a new view. I'm going to do no stadium roof. Just name it that. And then I'm going to open the no buildings view, which brings you back to the same scene but without any buildings. And then go back to the no roof view. And there we go. Our buildings are back and our roof is gone. So yeah, so very useful for setting up sort of excluded elements from the view. So that way you can redo an export with the same excluded elements. That's pretty much most of what we have here. You can go through the model tree to manage visibility on a hierarchical, keep double clicking, on a hierarchical level. You can also look at hide entire categories. There's only one in this model, so it's not very useful. But that covers most of the visibility tools that we need here. So with that said, we can actually just start exporting our model here. So I'm going to combine, like I said, I'm going to keep the same origin offset. I'm not actually going to filter it. I'm just going to hit export, and I have little Datasmith exports here. I'm going to make a new one. I'm going to call it Stadium Demo 2. And then you can just wait for this to finish. Actually, while this is going, I might as well open up Unreal and start a new project. So I'm going to launch Unreal Engine 5, which we recently started supporting. That export should finish soon. So in Unreal, I'm going to go straight for the architecture templates and choose a blank one. The thing that's important about choosing architecture templates is the Datasmith plugins are only activated in them. You have to manually activate them otherwise. So in order to avoid having to do that, I'm just going to use the architecture blank. Let's just get that started. And we can actually see that because that toast is gone, that it actually finished exporting. Unreal's loading up our new project. So let's actually navigate back to the home page here. And we're going to install our plugin. So the first step of starting a new iTwin project that has support for the iTwin Datasmith pipeline is to add in our plugin. So in order to support more Unreal Engine versions, we actually let you recompile it from source. So that's what this install button does. So we're going to navigate to that Unreal project that I just created, and you just select the U project after you hit the install button. So I'm going to hit install. It's going to add a new plugins folder there. And unless you're using the latest version of Unreal, you will have to recompile that. And it also depends on when we officially support the new version. But as of today, in this video, we are supporting Unreal 5 as the latest version. So what I have to do is reload now that I've added the plugin. So I'm just going to use the Epic Launcher. Should start up, but this time it should load the plugin. Yep, it's starting up here. Alright, great. So it didn't ask me to compile. It might for you if you're not using the exact version that the plugin is designed for, but it is guaranteed to compile as long as you have the dependencies for it from 4.26.1 and on. Actually a bit earlier, but there is a bug in the Datasmith importer in 4.26.1 and earlier, or 4.26.0 and earlier. So watch out for that. If you do need to recompile it from scratch, then you need to make sure we have the list of requirements in our tutorials. You need to make sure that you have Visual Studio installed, and you need to make sure that you have the game development C++ and the .NET C# workloads installed so that the Unreal editor can recompile things as it needs. And no matter what, that's actually going to be a requirement. If you're shipping an Unreal game, you will need to recompile the plugin for the shipping engine version. So no matter what, you are going to need to recompile it. You are going to need Visual Studio at that point. But the latest version is supported without it. So anyway, let's start our import now that we have it. So I'm just going to hit the Add Stuff button in Unreal 5 and just under Datasmith File Import. Again, that will only be visible if you have the Datasmith plugin installed. Actually, before we do that, let's real quickly make sure that we have the right plugins installed. So I'm just going to search iTwin in the plugin menu, and here we have it checked. So that's how we know that we have it installed. So now then I can hit the file import on Datasmith again, go to the Datasmith exports and select that Stadium Demo 2 that I created and just drop it straight into my content folder. It's going to take a bit to load. Alright, so just loaded. You'll see that the large static mesh isn't actually there yet. It's still being prepared. If it's a big one, it might take some time. I'm just going to change the camera speed here to 6, so that way I can fly in faster. I'm going to wait for that to load. We can actually go into the there we go. We can go into the content drawer, and in the Stadium Demo folder that was created when I imported this, there's an animations folder, which I'm going to go in and just drag and drop that schedule animation asset into the scene to get a level sequence actor into our scene using that sequence. So this sequence is going to guide the transform animated objects in our scene, like the cranes here, the things that actually move and rotate around. So everything else, for efficiency reason, is going to be animated through textures, through the plugin and shaders, basically. So we need to synchronize them, which we will do in a minute. So now that we've dropped that in, we can go and set in its settings here, autoplay, and I'm going to change it to loop indefinitely. And I'm also going to set the play rate to 3 times because it'll just be easier to get to interesting parts in the level sequence more quickly. Another thing that I want to do, just to make things a bit easier for us, is open the post-process volume and search exposure. I want to set the, so speed up and speed down. I'm going to set those to 20 each because it takes like 10 seconds for the exposure to properly adjust when starting the the level, and I don't like that. I'm going to grab our player start and move it so that we're staring directly at the building as soon as it starts. So let's bring it closer, and then this x-axis of this guy is going to be where he's facing. So let's change it 90 degrees. Let's actually have it look down at this thing, and then we'll see how it looks in a second. Let me grab that one more time. Yeah, the player start. Okay, there we go. So now we're staring at it nicely. So if I start, you'll actually see that things are already moving. What's not happening is that things aren't synchronized because of the way that the Datasmith API creates the level sequence. So we're going to synchronize stuff, and then we won't have floating crane heads. So to do that, let's search schedule in here, because there's one important item of our Datasmith scene called the schedule actor, which is what the plugin controls. And by coincidence, our schedule animation asset, our level sequence actor, really is already named schedule animation. So these are the two things that we're looking for. So I'm going to open up the level blueprint and drag that to be part of the main window. And what I'm going to do is I'm going to select our schedule animation, and then in the level blueprint you have this nifty feature where you can use the context menu to create a reference to that item in there. And I'm going to do the same thing for the schedule actor. Great, so we have a blueprint API to use from the plugin. So the schedule actor has a class in the plugin, which is why you need the plugin to load the scene, at least with the combined mesh scene. And we can just drag out our scheduled actor and access the API. So I can actually just click iTwin and you'll see all of our, I can type in iTwin and you'll see all our stuff. What we want, though, is correct level sequence end on begin play. So like I said, the Datasmith API doesn't let the exporter set the level sequence end correctly, so we just have a little blueprint function to do it for you very easily. And then the second thing we're going to do, I'm going to copy and paste these again with the schedule actor, is we want to synchronize. So I'm going to search synchronize. I'm going to synchronize the level sequence, and that just means that wherever the level sequence is in its playtime is where we're going to move the combined mesh, the schedule actor, to copy. So now if I hit play, we won't get floating cranes. Things are going quickly because we set the play rate to be 3 times, but there, now our cranes actually spawn together and rotate as necessary. And that's all good and well. So with those things in sync, let's actually do something interesting with the Blueprint API, which is going to be adding a little scrubber to our game here to scrub through the animation dynamically and let the player basically control it. So to do that, let's open up the content drawer and let's make a ton of classes. So I'm going to go back to content. I'm going to create a user interface item. I right-clicked here, by the way, to be able to add a new item. You can also just hit the add button here. I'm going to create a user widget. I'm going to call it timeline widget. I'm going to create a blueprint class that is going to be a HUD, so I have to open all classes there and search for the HUD class. Just going to name it HUD. Actually, I'm going to name it my HUD, so it's easier to find. I also need a game mode base. Just going to call it my game mode. And I need a player controller, which is also just here. I'm just going to call it controller. So let's set the world settings to use this game mode, so that way we can there. So in the game mode override for world settings, we're just going to override it to be my game mode, which will let us override other stuff such as using our HUD, my HUD, and my controller. And that will let us set our widget up to spawn on the HUD of this controller. So if I just go back to the content drawer and double click the HUD. Let's spawn the widget we created. I'm going to go to the event graph on begin play of this widget here. Sorry, on begin play of this HUD class. I'm going to spawn a widget, so I believe that's create widget. And I'm just going to set its class to timeline widget, which we created. And then immediately I'm going to drag this out and add to viewport. So this HUD is going to add the widget just created to viewport, and that's perfect. Although our widget has nothing, so we won't see anything in it. Now, we also want to open our player controller here and change some settings in it. So let's see. I want to show the mouse cursor and enable clicks and enable mouse over events. Why not? And I believe that's all that we're going to need to manipulate the screen and not have this thing steal the mouse from us. All right. So then the last thing that remains is to make our timeline. So I'm going to go a bit quickly with that because UI is a whole different subject. So let's see if we can do that quickly here. I'm going to get a vertical grid. Just going to throw a vertical grid in there and then throw a horizontal grid for the labels that we're going to use, and then we need a scrubber slider. I want a slider underneath that horizontal box. And then in this horizontal box, I want text. Text blocks. So I'm just going to throw 3 text blocks. Whoops. Just tried adding it to the wrong thing. Just going to give that horizontal box 3 text blocks. And I'm going to name them start, current, and end, because we're going to use the Blueprint API to attach to write the start, current, and end times of our schedule. I'm going to take this current guy, I'm going to set him to fill and give him the centering horizontal alignment, so that way we have everything in the middle nicely. I'm also going to set the padding of this slider, expand it, and I'm just going to set the bottom padding to 50, and actually the left and right padding also to 50. Whoops, that's the top, because we're going to move it to the bottom. Yeah, so let's get the vertical alignment to the bottom, and this horizontal box is also going to go to the bottom. Just need to set that slider to auto. Perfect. Okay, so I also want some padding on this horizontal box so it doesn't look super duper weird. Actually, let's make the slider have even more padding. Let's give it like nice, and then we'll just give actually let's make it even more. And let's just give this horizontal box a little bit of padding. Perfect. So one thing we're actually going to want to make sure is we're going to want to hit the is variable button on all of these. Make sure that these are variables because we're going to use them when we use the Blueprint API to insert some text on them. Actually, the padding's a bit off, but that's kind of okay. We can move on to the graph from there. I don't think there's anything else we need. Okay, so what we do need is to go down to the slider again and scroll all the way down, and then we need 3 events from here. So we want on value changed, because when the value changes we want to set the schedule, and when it gets clicked we want to pause the schedule. So let's go and let's capture both the on mouse capture begin, and the on mouse capture end. And we're just going to pause things there. So to get our stuff, in order to get our references, this isn't a level blueprint, so we cannot just fancily grab them. We're going to have to get all actors of class. We're just going to get actor class because we expect one. You may have to use some actor tags in your case if you have multiple. So I'm going to get all actors of class schedule. Whoops. That's schedule actor. And then I'm going to promote that to a variable in my blueprint. I'm going to name that to schedule actor. And I'm going to copy that. I don't need that. And you're going to change it from schedule actor to level sequence actor to grab our sequence. And I'm also going to promote that. Whoops. I want to grab that guy. Nice. And name it level sequence. Great. So what we want to do is pause our level sequence. Since the schedule is going to be synchronizing to it, we only really need to just pause it based on that, just on the level sequence basically. So let's grab this on begin. We're basically going to check if it's paused, and if not, we're just going to toggle on both capture and end. So let's grab our level sequence and then check if it's paused. Whoops, that's not what I want. Just want to clean that up a bit. And then branch. So both of these are going to go there. And then if it is paused, then we want to play. Let's do it this way. Pardon my dirty blueprints. So we're going to want to pause if it isn't paused. And then that should have it pause when we start trying to manipulate it. Great. So then the other thing that we want to do is we want to actually set the value of where level sequence is at to scrub when the value is changed. So we get a value between 0 and 1, and we want to convert that to a part of our level sequence. So let's do that. Let's grab our start time and our end time, and we're going to convert the 0 to 1 value to a start time and end time, sorry, to the middle time. So I'm going to get the seconds equivalent of this, of the frame time that's actually in the level sequence, because that's all we really need to do this. So we want to convert the 0 to 1. So what I'm going to do is I'm going to use a lerp, because the lerp just takes the 0 to 1 value and then blends between the two parts. So that's exactly what we need in this case. So we're just going to blend between those. And the return value here, we're going to, so this is going to be the seconds. So we want to set, or actually going to grab it from this guy. We want to scrub to a frame. So I don't think it's scrub, it's a set playback position. That's what we want. And we're going to make a playback parameters, and it's going to set the position type by time rather than frame, and we're going to give it that time. And we're also going to set the update method to scrub. I actually do not very well know the difference between them. There are some minor differences between the update methods, about like which events get in the level sequence get updated and whatnot, or played, but there is a slight difference. Alright, so with that done, we should be able to check out if it works and then see if there's anything else we need to do. So everything's grabbed. Let's see what we forgot to do. So when I hit play, okay, so we forgot to set the so we forgot to update the slider on tick, and I forgot to update these values. So let's do that. So first thing we do on tick is we're going to set the slider value. So I'm going to grab the slider variable, and I'm going to set the value. And we want to set the value. Basically, we're going to do the reverse of what we just did, except that's going to require more math than using just the lerp node. So let's copy and paste this over because we're going to use it. But we're also going to want to get the current time in seconds. So get current time and translate it to seconds for that nice blueprint math. So we want to do the reverse of a lerp, which means we want to, do some subtractions. So we want to first subtract the start time from both of these, basically the start time from the end and from the current, and that'll give us the two magnitudes, which we can then come up with a proportion by dividing. So what proportion is the current magnitude from the final magnitude? And that actually gives us our value. So I believe that is it. There are a couple of things we're going to want to do on tick. So I'm going to move this over here. Just going to create a sequence because I think it's going to look nicer. Maybe. We'll see. And we're just going to set our start and such. No, we're not actually going to use the level sequence for that. We're going to use the schedule actor. So the schedule actor has an actual date associated with it. So the animation time is stored as a date, and we're going to use that. There is a as date time. Yes, there's a way to convert it to text called as date time. It's kind of hard for me to find, but we have a deprecated utility for getting the date, but this is better. So we're just going to do this. So that's the animation time. We also want to get the start time and the end time. So let's do start, get animation start time, get animation end time. Great. And then just going to copy this over a couple times. And going to, we're going to grab the start, and we're going to set the text, and it's going to be, oops, that's the current. So, animation start time, and then I'm just going to copy this a few times, and then this is going to be the animation time. So that's going to be get current, and this is going to be end. So these are the text labels that we created variables to. And let's hook these up. I wish I did these in order. I guess that's not too hard to fix. There we go, good enough. And now it's going to set that, so we're just going to hit play. Okay, and now you can see that April 20th, 2022 is the start, and the end's February 29th, 2024. And the center is going crazy, and the slide is updating, and we can click on it if we can catch it, and move it ourselves, and see the current time updating, everything moving, all these cutting plane animations coming in, cranes going away and whatnot, things moving. So that is a full link up with the Blueprint API and control over our nice schedule. The Blueprint API, by the way, is in our manual. So if you go to our documentation that I referenced earlier, there's a Blueprint API reference which will list the classes. You can also go into the actual plugins since, like I said, we ship the source. So if I want to go to settings, show plugin content, I can take a look at the actual plugin materials, which you can play with if you want to change stuff. But you can also open the C++ classes and just open the scheduled actor yourself. Don't know why that's doing that, but so you can take a look at how we feed the animation data into the combined scene. Obviously, if you're not using the combined scene, or if you want to play with the transformed elements, then you're going to want to open the schedule animation. And then you can scrub through it there. I guess there's one thing that I almost forgot that I'd like to do, which is take a look at adding a fancy material, because one of the advantages to Unreal is the excellent material systems, and you can use pre-built materials, huge libraries, and lots of marketplace content. So let's see if I remember how to do that here in Unreal. So I believe if I there we go. So if I go to starter content, we can find some materials, and we're going to throw a new glass material on these windows, and then we're going to, let me turn down that camera speed that I turned up earlier. That's much better. Let's drag and drop in a glass material here. It's a little bit too see-through. Maybe there's a different one. Not really, but we can edit it because we're going to have to anyway. Because the animation is shader driven when you are using the combined mesh, you actually need to opt into the visibility controls that the shader uses in any custom shaders that you apply. So that goes for our glass here because it has its own form of opacity, and really all materials do. They're all generally, fully opaque, not transparent at all. When the clip plane animation occurs, you'll see the cutting plane. You'll see that, you'll see a number of issues by using the glass material, but it just is there. It's no longer hiding until its part in the animation comes up. So we're going to fix that real quick by using the material function. So what you want to do is just call a material function. So there's a material function call node, and we're just going to use it's called the SYNCHRO visibility animate, and it's inside the plugin. I believe it's possible in some configurations that you actually need to, in the content drawer, activate the plugin. So what I did earlier, where you go to settings and hit show plugin content, that may be required sometimes if you don't see it coming up. So yeah, so we have this, and what we want to do is we want to combine our original opacity with the SYNCHRO visibility, with the output of the visibility in the animation, basically. So we're going to use a multiply because that's basically going to say whatever the animated visibility is, make sure that our opacity only reaches like a maximum of 0.35. Yeah, so it's like an AND operation between these. So the opacity of 0.35 and only be visible when this thing says so. And you might have noticed, or you will in a second after I apply this, that there's still going to be shadows even with it invisible. So if we scrub through it again, you'll see that there's still shadows. So we just want to disable that. You can just look up shadow here. Oh, whoops. Forgot to select the right thing. Got to select the material output to look at this. So you don't want to cast ray trace shadows basically when you're translucent material here, because otherwise they're going to show up even when the translucency or the opacity is at 0. So now when we play, they won't show up, but there will be one more problem, which is kind of hard to see, I think. Yeah, there. So there's like a little bit of refraction going on where the windows are. That's hard to see. Okay, now that we're zooming in close, you can see a lot better. So we want to disable the refraction in the shader itself using that visibility material function. So what I'm going to do is, here's the refraction setting down here. I'm going to hit if, and I'm going to basically say if our visibility coming from the shader is greater, if it's equal to or 0, so basically if the thing's not visible, then we want our refraction to be default. So the default refraction, the refraction of a vacuum, is 1. So I'm just going to set the value of this to 1. And like I was saying, so the things we're comparing are the SYNCHRO visibility animation and to 0. So basically if it's greater than 0. So our const b is actually already set to 0. Great. So If it's equal to 0 or less than 0, we want the refraction to be 1. Otherwise, we want the refraction to be whatever the material already wanted it to be. And, whoops, plug that into the wrong thing. There we go, our B is set here as the value. And now when I apply it, that refraction should be gone. Well, gone once we play. So we should no longer have any visual issues, but when we actually get to the point where the glass starts building out, we should see our glass come in with the standard cutting plane animation. So no more refraction here. Trying to not go inside the building during the build-up. There it is. Okay, so should soon be getting our building. There we go. So now our glass, our high fidelity material builds up, and we could just populate the entire scene with high fidelity materials like that, and have everything looking like a real, like it's using real Unreal materials, because it will be. So I'll just plop in one more, and then I think that'll be it. I don't think these kind of buildings are made out of bricks, but maybe it'll look okay. We'll see how the UVs are. There we go. Okay, great. So now we have our brick glass building in Unreal Engine. You can see the same materials actually. It's derived from the colors in the model. So you'll have to set different base colors for each item. But if it shares the same color, it shares the same material slot in the combined mesh. So presumably we probably want to choose not bricks, since we don't want our stadium to be bricks. But yeah, you can also just change your source information to have separate colors, and that will split up the material slots if that's what you want to do. And yeah, so all our glass is applied because they have the same material slots, and we could go through and do more stuff. But that's basically that. You could even put this in a data prep recipe, and even though data prep recipes, like I said, aren't great for combined meshes because so much stuff isn't there, you can still set up a material substitution table, and then just, if you ever need to re-import this stuff, get all your materials placed in the correct material slots instantly. So that'll make it a lot easier and faster, and that's a great thing about having the integration with the Datasmith pipeline. With that done, really it's up to you to customize your iTwin's geometry and using the data through any data prep recipes to get your iTwin and all your engineering data and connected models into Unreal here, and just use the tools in Unreal to do whatever your heart desires with this stuff. So thank you very much for following along as we went through this. If you have any questions, I would encourage you to go to our ideas portal, which you can access through the little help icon. You can go straight to the feedback and try to get involved in voting and adding suggestions or feedback for us. And we'd love to hear from you guys. So thank you very much. I hope you have a good time using the exporter and get as much of your data as possible through. There's a lot of huge data out there, so I'm sure you'll see things. But please reach out, and we're going to try to make sure that as much and as large as possible scenes can make it through. Thank you for watching. Now back to Jason.